Hi, my name is Nils. I'm one of the co-founders and CEOs of DigiFarm. I'm also a 15th generation farmer and crop producer here in Norway. And I'm going to talk a little bit about the project Sen4Weeds, which we were lucky enough to get funding through the AI4Copernicus first call. And we're thrilled to be here and thrilled about the opportunity to be able to build this solution. So I figured I'd start with a few slides just to talk a little bit about my experience and the history and why we're doing this. And also to mention there's 3 partners here, of course, 2 technical, both DigiFarm and ALTYN, Swiss-based agtech startup who's helping us with the imagery side, and then a third non-technical, which is Farmen, which is this farm here you see in Hamar, Norway. It's an hour northeast of Oslo. This is where I was born and raised. And this is where also the initial POC and testing phases started. And you can see here a little comment for me, but it's been in my family for 500 years, and it's not a big farm. We have about 80 hectares of cropland and 80 hectares of productive forestry. But I took over the family farm 9 years ago, and the preface of this project, of course, is to deal with in-field weed detection. Myself, I see from the seasons and I mostly do spring wheats and barley, but I see from the seasons we're getting a lot more variability and patterns in the weather, which means that we get more rain at once or hotter summers, and this is causing a big issue on the weed infestation. We significantly see this over the last few years, and from my personal experience here in Norway, we deal a lot with wild oats, which is a significant problem, which also has to get manually controlled, manually walked throughout the fields every summer, pick the weeds, and also have to burn these and notify it to the authorities. So it's a very manual process. It's a very complicated process. Also, the ability to have weed infestation makes a big difference on the crop yield. So, and the challenge that we started with this, of course, is that weed management is manual. It's time consuming and very costly. As I mentioned on the slide before, I have to walk my fields every summer and look for wild oats, and these patches aren't typically quite large, and also they look sometimes a lot like barley when you're in wheat fields, so it's very difficult, but it can result in 100% yield loss. And one of the things too for us in Norway, if we declare having no weeds in our field, wild oats specifically, for a certain amount of time, a period, we also get higher compensation or pricing for our grains, so it's a significant point. And we look at the US, for example, weed loss results in $33 billion in lost crop production every year. Overall yield loss in grains worldwide is about, say, 10%, which is, 200 million tons of grain. We think about, of course, the global food production and population growth. It's incredibly important and critical to be able to solve this puzzle. And the solution here that we put together is automatic weed detection using artificial intelligence and super resolution satellite Earth observation data. And as we mentioned in the beginning of this project, is that imagery is very expensive, both drone imagery, so UAV, but also commercial grade satellite data from Planet, Airbus, or Maxar, because you need very high resolution data to be able to pick up these automatic detection of weeds in fields, specifically when we talk about 3 by 3 meter patches. And this is very expensive, so it becomes a very cumbersome, challenging process for farmers. But here's the idea to reduce weed management costs by up to 90%. The process I mentioned earlier, how I go in the fields and do this. I wanted to go back in here and talk a little bit about how the process happens that we do this. The big part here is imagery. So what we do is we do a super resolution on Sentinel-2 from 10 meter to 1 meter per pixel. So what you see on the left-hand side to what you see on the right-hand side, this is done using 10 spectral bands, both L28 and L1C. And you can see it's a significant difference in the spectral quality and the data that we get from the data. And this is significant when we talk about weed patch detection. And this is the exact AOI that we did the POC and also did our first commercial trials in Brazil. Also, you can also see the difference between here 3 meter planet scope with 8 bands and also the 10 bands, 1 meter per pixel. So the key to having the ability to detect weed early in season in particular boundaries or agricultural land is, of course, field boundaries, delineation of field boundaries. So that's the first key point for us, is to have a tool that allows us to do automatic field detection in season, and then run weed detection on top of that particular data layer. And here you can see an example of what DigiFarm provides. It's automatically delineated field boundaries using 1 meter per pixel solution Sentinel-2 at 10 bands. And this is delivered now through the API, which enables our clients to consume this through the API in the season, and enabling them to be able to layer on top the data stacks for weed detection. And one last thing I wanted to mention is that we also have a partial deep resolution, which was part of our technical infrastructure, because the ability to have in-season high-resolution imagery on boundaries and then run weed detection is significant and critically important. So what we have here is the ability to have any B-box in any particular area and super resolve that from 10 meter per pixel to 1 meter per pixel on the fly. And then we layer in the weed detection and data layers on top. So you can see here the left is the 10 meter per pixel and the 1 meter on the right hand side. And this is, of course, in the same AOI we had the weed detection. And here you can see the actual outcome of the weed detection methodology that we developed. And we focused on pre-closed canopy, of course, early weed detection in the season. Patches are typically 3 meter by 3 meter. And of course, we had UAV and reference data from this particular area in Brazil. And we managed to achieve an accuracy of above 80% on weed detection in field and season, which is significant for us. And of course, then this gets delivered in the API along with the different solutions. So, and of course, diasynchronous and the Copernicus imagery is critical to this infrastructure. Of course, it enables us to have this immediate or infrastructure where we do instant on-demand queries for deep resolution boundaries and also the weed detection on top. And we managed to get quite a bit of significant commercial interest already. We're running now pilots of BASF, but also Old College in Canada, along with KWS and our other corporate partners to be able to scale this out. And it's been incredible and would not be possible without the help of course, the AI4Copernicus team and the funding through this grant to be able to solve problems like my own in Norway, to be able to have in-season early weed detection, which would, from my own, personally stepping back also from my own personal experience as a farmer, that this is a significant step forward to be able to provide these solutions for farmers in season, as it's a very cumbersome, challenging process, time consuming, and it has probably one of the highest risks for crop reducing yield. So thank you so much on behalf of myself, Josef Ackman, Konstantin Warwick, ALTYN, Farmen, Gard, and DigiFarm to be able to do this project. Thank you so much.